All right, I want to recap what we did yesterday with the vertical motion problems. I don't feel that the lesson went quite as good as it could, as we're applying what we learned with the quadratic functions, both by solving for our x-intercepts by factoring, and then what we applied with solving it with the quadratic formula. Our function here, d equals rt minus 5t squared, we talked about yesterday. This is our quadratic function as it applies more of a real-life situation. The examples up above, it talks about that the distance is equal to the initial velocity, which is a constant upward velocity, times the time in which the object has been in the air, subtracted by the distance. This is the force that gravity is enacting on an object when it's been thrown or kicked or shot or otherwise. The application of this becomes more complicated because we talked about our standard form of quadratics. That is, what is the standard form of quadratic? Don't be shy. What is standard form? ax squared.
ax squared plus bx plus c equals 0.
Okay. All right, so we've got our standard form. When we worked out the quadratic formula, we needed things in standard form so that we knew what our a value was to substitute, what our b value and c value was to substitute into the quadratic to solve. Our equation to begin with, is that standard form?
No.
Not necessarily. Not unless our distance above our initial point is 0. Okay? My a value is my -5. That's going to be constant. My rate, if trying to find the time, my rate will be that initial velocity. Which variable in this formula, or vertical motion formula, is equivalent to x in our standard form as we've known it? T. Okay? That's something to keep in mind. Our t, which is time, is equal to our independent variable, x. That way, when you're asked a question, what does that point 320 mean? It means at 3 seconds, the object is 20 meters above its starting position. And you can apply the point 320 to the meaning of the problem. Most of these problems did ask you at the end to draw a picture. I would advise you when you work these out to draw a picture to begin with, to start that picture the best that you can, and label it as you go. I did it in 7th period yesterday, and that lesson was so much easier with something to point to on the board and something to look at for everybody. Okay, in the first problem, in this football problem that we'll talk about, there's already a diagram drawn for you. You can see me looking like a goofball, kicking a football into the air, flies, and it hits the ground somewhere else. Okay, remember, nowhere in this vertical motion, which is up and down, can I find the distance that this object covers. My d is not the distance horizontally, it's the distance above where it starts. Okay, so it's not 3 seconds it flew 20 meters, it's at 3 seconds it's 20 meters high. Alright, let's read through it. A football is kicked into the air with an initial upward velocity of 25 meters per second. Okay, given that situation, what do I know so far about my function? Do I know my distance above the starting point?
No.
No. Do I know my rate?
Yes.
What does r equal?
25 meters per second.
25 meters per second. So I've got my d is equal to 25 times time minus 5t squared. And now I can either solve for time or I can solve for distance. Your rate for what we're doing with this, your rate will always be given. Okay? You're not going to solve for B. A asks you to calculate its height after 2 seconds and after 3 seconds. And although it didn't ask you to until part C, I want to put these dots on the diagram as we go. I want to show you the calculator. Okay, I want to use the calculator. You're going to get to use it in life. You're going to get to use it on your exam. So it's important that we learn how to use it. And